We're located at the oil seeps, the heavy oil seeps between Santa Paula and Ojai, California. I'd like to show you what this heavy oil looks like. It just literally seeps out of the side of the hills. It's just a very unusual, unique place. This is probably almost like tar. You can't pump this oil unless you introduce a surfactant, a chemical, or something like that, some hot steam or something to get into the formation. We're taking samples of it, and what we're going to be able to do is show you that we can take this heavy oil and we can break it down with our bio-EOR catalyst that we've designed specifically for the use of producing heavy oil from oil and gas formations that are anywhere from 600 feet to 10,000 feet deep. We're going to take some of this heavy oil. Okay. You see how thick that is and viscous. You just can't pump that in any oil well. Now, most heavy oil is recovered by several methods. The most notable in the state of California is steam. And there are a lot of problems with steam. Corrosion problems, tremendous amounts of water is used, and a lot of natural gas is used in the process of making the heat of the energy to be used to make steam. We've come up with a new solution, something that's 99.9% biodegradable. We use no water, no steam. We inject it directly into the formation. This is what it looks like. It looks like oil. It comes from oil. We have 35 different types of oil that we can use when we make our product. Then we mix a special catalyst with it, and this is what we get. Now we're going to show you that very thick oil that we just put into that container. We're going to show you what our product does to it. Normally, we would inject this in the formation, right at what they call the perfs, in the casing of the formation. And I will demonstrate that to you in a moment. But for right now, let's see what we do with this. This is how thick this was. Look at this. You can't hardly even pick it up. Okay. It took us about 2 minutes to put our material in there. Now remember, we would do this in the formation under pressure. Now, this is what is incredible about this material now. The heavy oil, this heavy oil over here, when it gets cooled, or when air mixes with it when it's coming up out of a well, if it can be pumped, which it cannot unless you use a chemical, that will get hard again in about 2 to 3 hours. What we've done here now with this, it'll never get hard again. The viscosity that we've changed, that probably 9 gravity oil, is somewhere around 20 gravity oil. That means we've upgraded it in the formation, which is in itself a feat that's never been done before. And this heavy oil now will never go back to this original viscosity, the thickness of it, what it was originally. These old wells have been sitting for 15, maybe 20, 25 years. We'll need to go in and rework each one of these wells. What does that mean? We'll go into each well, pull the old rods and tubing out, check them, make sure they're in good shape. If they're not, we have to replace them. And we'll gravel pack the bottom of the well to make sure that we can physically produce the oil that we're going to stimulate to come back through. Funnel extensions will come out into the zones, and we can go out as far as 1,000, 5,000, 10,000 feet, as far as 30,000 feet. And then we can go into the upper zones. And by the way, some of these oil wells with the heavy oil are as shallow as 600 feet, all the way down to 10,000 plus feet. So it's a great opportunity to revitalize these old wells. This is our injection tool. If you can see the little holes here, these are the holes that allow our fluid to go out into the formation under pressure from the surface, and will go into these deviated horizontal laterals from the heel to the toe, heel to the toe, and then go out into the formation in a 360-degree manner. The fluid is heated to a desired temperature, and once it starts contacting the oil and expands the molecules, the oil will then begin moving to the old wells that we recompleted, and the oil will come up and will be pumped into our holding tanks. Now, this will not obviously flow on its own. I can't even get the handle out for that, as you can see. Now, the same oil that we were able to break down, sitting right next to it, and I'm going to show you what we're going to do with that. This is the exact same oil that we worked with 2 days ago. That is that same oil that you just saw in that big container. And there's any of the lumps that you see in there are pieces of dirt and leaves that were encased in that heavy oil. Isn't that incredible?
Welcome to an introduction of our mini refinery. We appreciate you taking the time to view this video. We've attempted to give you a complete overview of how our system works and how it can be an asset to your company. This unit is a VFD or vacuum distillation unit capable of processing 1,000 barrels of distillate per day. Our units can be configured from 300 to 20,000 barrels of crude per day production. These mini refineries are designed for rapid assembly once on site and operate with minimal staff support. These mini refineries are designed to run completely automated, and once an operator sets all the controlling points, all product temperatures and flows are controlled automatically. If a product specification drifts off, or if a potentially hazardous condition develops, the mini refinery automatically adjusts itself to a safe condition without the help of an operator, and a first out annunciator signals the reason for the shutdown by a flashing red light. The operator can then make the necessary adjustment, or the mini refinery will automatically shut down. The mini refinery only requires a flat support area or concrete slab without anchor bolts. Most systems do not require water, steam, or instrument air. Fuel supply can be natural gas, naphtha, diesel fuel oil, or a combination of these fuels. This system is equipped with filters that collect most solid particles when the feedstock first enters the mini refinery. This mini refinery also contains bypass systems for reprocessing distillates in the event the system detects that a specific distillate needs further refining. All system piping is constructed with maintenance in mind, so valves and gauges are installed at convenient places in order to make operating a mini refinery manageable with minimal staff. Our mini refineries come complete with a software package to manage and control the mini refineries. Process flows and system emergencies can be viewed and responded to via the control system. The system shows the functions of the mini refinery in real time to make operations very simple. Depending upon the need discovered in the design process, we can allow control of storage tank levels, open and close tank valves or piping routes, move distillates from one storage tank to another, blend distillates for delivery to transport vehicles, check on emission levels being produced by the mini refinery, all these features from the same interface that controls and runs the mini refinery. There are also many options that can be added to the mini refinery to further enhance the processing of distillates. Options for the mini refinery include a desalter package, sulfur removal package, reformers for producing high-octane gasoline motor fuels, gasoline stabilizers for reducing the reed vapor pressure of motor fuels, asphalt vacuum units for producing U.S. specification AC-10 asphalt, winterized skids for operation in Arctic weather, and portable laboratory and control buildings with supplies. As you have seen, there are many reasons to purchase a mini refinery. If productivity and scalability are important to your operation, talk to us about using a mini refinery to do the job of a full refinery for a fraction of the cost, manpower, and overhead. Thank you for taking the time to learn more about our mini refinery solutions.